Welcome. Today we will see chapter number 5, that is steady state analysis and transient response. Now first of all we will see steady state analysis. Now first point is general block diagram representation for a feedback control system. Now this is the feedback control system in which first is input V is there to the element A. After that element A, R is the output from element A, which is fed to this summing point having positive signal. Then next block G1D is there. From that output M is there. It is fed to this another summing point. Then to this summing point another signal is coming, that is positive, from the element B, and to the element B U is the input. Again from this summing point, this is the output which is fed to this block G2D, and from this block G2D output is C. And again here this is known as takeoff point, and from this takeoff point this feedback signal is taken and it is given to this feedback element H of D, and it is fed to this summing point. Therefore we will see what is the analysis of this diagram. The equation describing the steady state operation of a control system is obtained by letting d is equal to 0, that is d by dt is equal to 0, in the differential equation of operation of a system. Similarly, the block diagram that describes the steady state operation of a system is obtained by letting d is equal to 0 in the general block diagram representation for a control for a system. The block diagram which describes the steady state operation of the system of above figure is, that is figure A is, this is the block diagram which represents steady state operation of the system, in which two diagrams are there, or this diagram is divided into two diagrams. First is controller unit and next is system to be controlled. This is the controller unit and this is the system to be controlled. Therefore KH is the feedback element, V is the input, also U is the input. Therefore we will see different equations from this diagram, where V is the command signal, C is controlled signal and constant, as well U is disturbance signal. Now Kg1 is equal to G1 of D at D is equal to 0, Kg2 is equal to G2 of D at D is equal to 0, and Kh is equal to H of D at D is equal to 0. For controller unit left half shown by dotted lines, we have the manipulated signal M leaving block Kg1 can be given as AV minus KHC into Kg1 is equal to M, where is a constant, M is a constant. Therefore AV into Kg1 plus KHC into Kg1 is equal to M. Therefore minus KHC into Kg1 is equal to M minus AV into Kg1. Therefore C is equal to M minus AV into Kg1 divided by minus Kg1 into KH. Therefore C is equal to minus M divided by Kg1 into KH plus AV Kg1 divided by Kg1 into KH. Therefore C is equal to minus M divided by Kg1 into KH plus AV divided by KH. Equation 1. Now for various plots for steady state characteristics for a typical controller unit, lines of constant values for the command signal V are plotted with the controlled variable C as the abscissa and the manipulated variable M as an ordinate. Therefore, from equation 1 for v is equal to 0 or v is equal to constant, we have put v is equal to 0. Therefore, c is equal to minus m divided by kg1 into kh plus a into 0 divided by kh. Therefore, c is equal to minus m divided by kg1 into kh. Therefore, kg1 into kh is equal to minus m divided by c, or minus kg1 kh is equal to m divided by c at v is equal to 0, which is equal to delta m divided by delta c at delta v is equal to 0, which is equal to dou m by dou c at v is equal to 0. That is, change in m with respect to change in c when v is constant. It can be shown by following way. Means this dou m by dou c at v is equal to 0 is represented by this graph. Since its value is negative, that is minus kg1 into kh is equal to dou m by dou c at v is equal to 0. That's why these lines are like this, means their slope is negative. As kg1 into kh is equal to minus m divided by c, that is negative slope lines. That's why these lines are like this. These lines are having negative slope. Similarly, from equation 1, in which if c is equal to 0 or for c is equal to constant, we have 0 is equal to minus m divided by kg1 into kh plus av divided by kh. Therefore, m divided by kg1 into kh is equal to av divided by kh will get cancelled. Therefore, m divided by v is equal to a into kg1. Therefore, a into kg1 is equal to m divided by v at c is equal to 0, which is equal to delta m divided by delta v at delta c is equal to 0, which is equal to dou m by dou v when c is equal to constant. That is, change in m with respect to change in v when c is constant. The controller plot for above condition is, that is, c constant line is a vertical line in adjoining figure. These are the vertical lines which indicates constant lines. Dou m by dou v when c is equal to constant determines vertical spacing between the lines of v constant lines. Now, from equation 1, when m is equal to 0 or m is constant, then c is equal to minus m divided by kg1 into kh plus av upon kh. Therefore, c is equal to 0 divided by kg1 into kh plus av upon kh. Therefore, kh upon a is equal to v upon c at m is equal to 0, which is equal to delta v upon delta c at delta m is equal to 0, or which is equal to dou v by dou c when m is equal to constant. Therefore, kh upon a is equal to dou v by dou c when m is constant. In another way, that is, dou v by dou c when m is equal to constant indicates horizontal spacing between constant v lines. Horizontal spacing like this. And this is known as vertical spacing. This is known as horizontal spacing. Horizontal spacing, vertical spacing. For right portion in figure B, that is for system to be controlled, we have m plus bu into kg2 is equal to c. Therefore, m into kg2 plus bu into kg2 is equal to c. Therefore, c is equal to kg2 into m plus b into kg2 into u. Equation 2. When u is equal to 0 or when u is equal to constant, we have c is equal to kg2 into m plus 0. Therefore, m divided by c is equal to 1 upon kg2. Therefore, 1 upon kg2 is equal to m divided by c when u is equal to 0, which is equal to delta m upon delta c when delta u is equal to 0, which is equal to dou m by dou c when u is equal to constant. And when c is equal to 0 or c is equal to constant, we have 0 is equal to kg2 into m plus b into kg2 into u. Therefore, minus kg2 into m is equal to b into kg2 into u. Therefore, minus b kg2 divided by kg2 is equal to m divided by u. Therefore minus b is equal to m divided by u when c is equal to 0, which is equal to delta m divided by delta u when delta c is equal to 0, which is equal to dou m by dou u when c is equal to constant. Similarly, when m is equal to 0 or capital M is equal to constant, we have c is equal to 0 plus b into kg2 into u. Therefore c is equal to b into kg2 into u. Therefore b into kg2 is equal to c upon u when m is equal to 0, which is equal to delta c upon delta u when delta m is equal to 0, which is equal to dou c by dou u when m is equal to constant. Therefore the system to be controlled characteristics can be as. Therefore this is the graph. On y-axis m is there, on x-axis c is there. Therefore dou m by dou c when u is equal to constant indicates slope. This is the positive slope. These lines indicates positive slope. Similarly dou m by dou u when c is equal to constant indicates vertical spacing between constant u lines. These are the u lines. This is the vertical spacing, that is vertical distance between two lines. Vertical distance between two lines, it is known as vertical spacing. Similarly horizontal spacing means what? Dou c by dou u when m is equal to constant. Horizontal spacing between u constant lines. Horizontal distance between two u lines. These are the u lines. This line indicates values of u. Whatever these inclined lines are there, this line indicates values of u. And distance between two u lines, that is horizontal distance between two u lines, is known as horizontal spacing. Vertical distance between two u lines known as vertical spacing. Now we will see the problem based on this theory. The block diagram representation of an engine control system is shown in figure. The reference operating point is Vi is equal to Ci is equal to 100, Mi is equal to 50 and Ui is equal to 10. Determine the steady state constants for this system and then sketch the steady state operating curves. Therefore this is our diagram. Whatever same diagram is there, we will compare this diagram with our standard diagram. This is known as G1 of D, this is known as G2 of D, this is known as H of D. This is the V input, this is U is nothing but disturbing signal. G1 of D means 1 divided by 1 plus tau 1D, G2 of D means 2 divided by 1 plus tau 2D, H of D means 0.5. Therefore solution, the steady state constants are B is equal to minus 5, KH is equal to 0.5. Therefore KG1 is equal to 1 divided by 1 plus tau 1D at D is equal to 0. Therefore KG1 is equal to 1. KG2 is equal to 2 divided by 1 plus tau 2D when D is equal to 0. Therefore KG2 is equal to 2. Therefore the value of A is equal to 1 divided by Kg1 Kg2 plus KH, which is equal to 1 divided by 1 into 2 plus 0.5. Therefore A is equal to 1. The slope of the operating curves of the controller is dou m by dou c when V is constant, which is equal to minus Kg1 KH. Therefore substituting the values, which is equal to minus 1 into 0.5. Therefore dou m by dou c when V is equal to constant is equal to minus 0.5. The line of Vi is equal to 100 may now be drawn through the reference point Mi is equal to 50, Ci is equal to 100 with a slope of minus 0.5 as shown in figure A. The horizontal spacing is delta V upon delta C when M is equal to constant is equal to KH divided by A. Therefore KH value is 0.5, A is equal to 1. Therefore delta V upon delta C when M is equal to constant is equal to 0.5. For delta C is equal to 20, then delta V is equal to 0.5 into delta C. Therefore delta V is equal to 0.5 into 20. Therefore delta V is equal to 10. When M is constant, a horizontal line, the horizontal spacing is such that as V changes by 10 units, C changes by 20 units. The vertical spacing is delta M by delta V when C is constant is equal to A into Kg1, which is equal to 1 into 1 Therefore delta m by delta v when c is constant is equal to 1. For delta v is equal to 10, then delta m is equal to 1 into delta v, which is equal to 1 into 10 is equal to 10. When c is constant, a vertical line, the vertical spacing is such that as v changes by 10 units, m changes by 10 units. Therefore these are the graphs, final graphs. This is the vertical spacing, delta m is equal to 10, delta c is equal to 20. Similarly, delta c is equal to 20 and delta m vertical spacing between two V lines is equal to 10. Horizontal spacing is 20. Similarly, vertical spacing between two U lines is 10. Or horizontal spacing is 20. Delta c is 20. Therefore, these are the graphs. Now, this third graph is nothing but the addition of these two graphs. Third graph, this indicates the addition of the two graphs. Okay, thank you very much. We will stop here. Thank you very much.